Hey guys, I'm going to go through the answers to the classwork since I'm not here today. So we'll just go through 1 through 12, starting with number 1. The same rules for natural logs apply to logs, which is what we learned last class. So we see that we have the natural log, which is just the log at base e of these two pieces here. So when we have log on both sides, all we can do, or all we need to do, is just cancel those out, and we've got 2v minus 10 is going to equal negative v minus 4. Now we want to go through and solve for v, so if I add v to both sides, I have 3v, add 10 to both sides, I have 6, so v equals 2. What we want to think about as we do these and as we check all of these, we want to think about what happens if I were to put that 2 back into my natural logs. So if I put it back into here, I would have 2 times 2 minus 10. That gets me a negative number. Same thing if I plugged 2 in over here. So let's think about what would happen, and I'll just do it for one of them. Negative 2 minus 4, so the natural log of that. Well, that's the natural log of negative 6. And we can't take a log, whether it's a log base anything or log base e, meaning the natural log of any negative number. And when that happens, we actually have no solution here. So we want to think about checking our answer for no solutions. So yes, we got v equals 2 when we solved using the proper steps, but we ended up seeing, oh, okay, well, I've got the natural log of a negative number, and we know that that's not going to work. Same thing over here, as the same setup, not the no solution part, but we have natural log of two things here. We can set those two equal to each other. 19 equals 2p plus 5. Subtract 5 from both sides, we have 14 equals 2p. Divide both sides by 2, we have 7 equals p. And so over here, our final answer, p equals 7. When we have one side, remember, same with last class with regular logs, all we have to do is put it into exponential form. But before I do that, I want to get rid of this 9 out front. I want to think about dividing both sides by 9. So I've got natural log of n minus 6 equals negative 2. So again, when there's a log only on one side, we convert this into exponential form. And I'm going to rewrite ln as log base e, just to show exactly what I'm doing, of n minus 6, and that equals negative 2. So we remember to go from exponential form, we take the base, we go to the piece on the far right, and then back over to that piece in the middle. So we would end up having e to the negative 2 equals n minus 6. With that, now I can add 6 to both sides, so e to the negative 2 plus 6 equals n. And this can go right into the calculator. The e button is above the natural log button, as we can see right here. So I'd hit second natural log, brings me to the e, plug in negative 2, and then tab out, add 6, and I get the decimal answer, 6.13 rounded to the nearest thousandths, 5. And so n equals 6.135. We'll do this similar process for number 4, except I'm going to skip this step. Again, I want just ln of something all by itself, so I'm going to add 1 to both sides. So I have ln of a plus 5 equals 4. I know that ln is log base e, so I know that I'm going to have e to the 4th equals a plus 5. And again, if you're confused as to where this comes from, it's going from logarithmic to exponential form, where the base is e. Natural log is log base e. I want to solve for a, so I'm going to subtract 5 from both sides, and this gets plugged right into the calculator, so I'll do that down here again. Second log, e to the 4th, tab out, subtract 5, we get our decimal. A equals 49.598. Clear out. All right. For this one, I didn't put parentheses in here because I want you guys to be familiar with, if there isn't a parenthesis here, this isn't ln. We're never going to have ln by itself. Ln, natural log, it's a function. We have to have an input for that function. So the input is negative 5p. So whenever you see something like this, and we see it again in number 6, put the parentheses out around it, even if they're not already given. So what we have here, let's add 10 to both sides. Natural log of negative 5p equals 7 plus 10, which is 3. Again, this is log base e, so to go from logarithmic to exponential form, I have e to the third power equals negative 5p. To solve for p, we have to divide by negative 5, and this goes into our calculator. Second to the third power divided by negative 5, we get negative 4.017. So p equals negative 4.017. And all this time, I'm going back and thinking about what value I would end up having inside my parentheses. So here, looking back at number 1, if I had 7, well, 2 times 7 is clearly going to be positive, so this solution works. 6.135 is bigger than 6, so if I subtract 6, I still have a positive number. 49.598 plus 5, again, positive. A negative times a negative, that's going to become positive. So this is, in fact, a solution. Okay, number 6. Let's divide by negative 6 to get the ln of our negative 7b by itself. So ln of negative 7b equals negative 12 divided by 6, which is 2. And then we take the natural log of 7b, so we've got e to the 2, so e to the second power equals negative 7b. I have to divide both sides by negative 7. E to the second power divided by negative 7 equals b. Calculator, natural log divided by negative 7, we get negative 1.056. So b equals negative 1.056. All right. 7 through 12. Solving equations. Okay, so again, we want to get our exponential piece by itself, just like we were getting the logarithmic piece by itself. So I want e to the n to be alone. So to do that, we have to divide both sides by 10. So e to the n equals 83 divided by 10. I have to convert this now from exponential to logarithmic. So to go from exponential to logarithmic, we think, okay, from left to right and then back again. So log base e of 83 over 10 is going to equal n. Okay, and this is the same as with logarithms, how we did it, just regular logarithms last class. So going from exponential to logarithmic. Well, we know log base e, that's natural log. Natural log of 83 over 10 equals n. So I can plug this entire thing into my calculator using the natural log button. So let's go down here, natural log of 83 over 10, and we get the decimal 2.166, or 116. So n equals 2.116. All right, looking at number 8, again, I want my exponential portion to be by itself, so let's add 5 to both sides. So we're going to have e to the n equals 81. I want to convert this again into logarithmic form. When I have e to the n, I can just rewrite this, again, this is log base e, as the natural log of 81 equals n. And so I'll do what I did over here again for this one as well. So I have log base e of 81 over, just 81, sorry, equals n. Log base e of 81 equals n. Log base e is the natural log. Put the natural log of 81 in our calculator, we end up with n being equal to 4.394. All right, looking at number 9, we want to get the exponential portion by itself, subtract 1 from both sides, e to the 8m equals 73. So the natural log of 73 equals 8m. I need to solve for m, so divide both sides by 8. Natural log of 73 over 8 equals m. This whole thing goes in the calculator. Natural log of 73 divided by 8, we get 0.536. So m equals 0.536. Looking at number 10, I have to divide both sides by 2. E to the v plus 3 equals 81 over 2. So I'm going to have the natural log of 81 over 2 is going to equal v plus 3. Well, I still want v by itself. What I have to do now is subtract 3 from both sides. So the natural log of 81 over 2 minus 3 equals v. In our calculator, natural log of 81 divided by 2 minus 3, we get that v equals 0.701. Number 11 has a typo. This should not be a 3, that should be an e. So 2 times e to the n plus 7 equals 30.8. So careful with this one, there is a typo. Alright, so the process is still the same. Get the exponential portion by itself. E to the n plus 7 equals 30.8 divided by 2, which is 15.4. So the natural log of 15.4 equals n plus 7. Subtract 7 from both sides, so natural log of 15.4 minus 7 equals n. And when we plug things like this into our calculator, I didn't explain it with number 10, but let's go through with number 11. We've got the natural log of 15.4 closed parentheses, and then we subtract the 7. If I did not include that, if I did 15.4 minus 7 all within, we would not have the same answer. So we have to make sure that we close the parentheses after we calculate the natural log of that value. So again, the correct answer is negative 4.266. And then one final one, to get the exponential portion by itself, add 5 to both sides. E to the x plus 7 equals 75. The natural log of 75 equals x plus 7. Natural log of 75, subtract 7 from both sides equals x. Plug that into your calculator and get negative 2.683 as your final answer.